Okay, so in this video and in the next couple of videos, let's understand what decision trees are and how do you construct a decision tree. So one way to think about what decision trees are is that, there are nested if-else classifier, right? So if you have one condition, if if this, then this, otherwise else this, then this, and then if one of these conditions is satisfied, you start the nested if else loop or nested if else classifier again. If this, then something, so on and so forth. That's one way to look at what decision trees are. Let me give you an example. Let's say that, I'm trying to classify uh, whether my gender is a male or a female, okay? Or whether a person's gender is a male or a female. So let's say if I have a less than some value x, then y equals male, okay? Otherwise, if it's greater, then I check whether let's say a is equal to height and this here is weight. Okay, so if I first check if height is less than x, and if that's the case, then y equals male or y equals female. Otherwise, if weight is less than y, then y equals female, or if that's yes, okay, and if it's a no, then y equals male, right? This is one way to look at how decision trees work. So decision tree can be thought of as a binary tree. I mean, a binary tree is also, in a sense, if you look at it this way, it's basically acting like an if-else classifier. So that's how decision trees work. So now, before we learn how to construct a decision tree, I'll also explain how decision trees are always axis parallel. Okay, so our conditions in the binary tree that we drew above, in this binary tree, all the nodes that aren't leaf nodes have some condition on them, and the leaf nodes classify whether the data point is a male or a female, right? So the leaf nodes basically classify the a dependent variable. They explain the different dependent variable. So let's say I have height over here and I have weight over here. So, my it was if height is less than x, right? So if height is less than x, let's say this point is x, then y equals female. And then I said that if not, if it's greater than x, and if weight is less than y, let's say this point here is y, then y equals female. Otherwise, y equals male, right? This is this is basically what I've drawn here. Is I've just drawn the graphical representation of this tree right here. And that's one way to think about a decision tree. A decision tree is always axis parallel, okay? The feature space or this threshold over here is always axis parallel. So eventually, if you have a lot of conditions, you go along doing a lot of axis parallel conditions, and that's how you get the decision tree. And decision trees are also very highly interpretable. It's very easy to understand. What is interpretability? It basically means, if my model gives me an output, that if it's classifying something as something, then I want to understand why is it doing so. If it helps me understand why it's doing so, if it's, let's say, uh, if it's easily scrutinizable, then it is highly interpretable. So decision trees are very easily interpretable, right? I mean, I can just say if this, then y equals 2 or y equals 1, whatever. So decision trees are also very highly interpretable. So in the next videos, we'll understand what some concepts related to how to construct a decision tree.